Okay, so you may start.
Audible po ba ako?
Parinig naman.
Thank you po, sir. Wait lang. Welcome to Sismogram. Before anything else, I want to uh, make some apologies for the background noise since we are uh, near in the national highway. Pero regardless of that, I will try my best to speak louder than the noise. Welcome to the Sismogram. First, let us put our username and password. Ayan. Let's fill it out and click login. Good morning to all and sundry. For today, we are the reporters of a specific topic named vibration and attenuation. This is yours truly, Lloyd Esmilio.
And I'm Kyle Magkasi.
And I'm Jessica Salaysay.
I am Jose Fernando Cabrera.
And I'm JL Nazareno.
And as such, we will be talking over the vibration and attenuation, their nature, elements, characteristics, and relationships. Ayan. As seen in the presentation, it is a GIF, literally. And it follows a certain path. You will be figuring it out kung ano ba ang meaning ng GIF na yan. Yan, vibration, its nature and characteristics. According to the Google Dictionary, vibration is an instance of vibrating. So, most of you will definitely question yourself, ano ba ang vibration? Because it's the topic itself. Vibration, as such, is an instance of vibrating. It's the most literal definition. But in the natural science, specifically in physics, it is an oscillation. Ano po ba ang meaning ng oscillation? Oscillation is a back and forth movement at a regular speed. So it's an oscillation of the parts of a fluid or an elastic solid whose equilibrium has been disturbed or of an electromagnetic wave. Giving you some definition, it is a mechanical phenomenon. So what do we mean by mechanical phenomenon? Mechanical means, di ba, it is related into motion. So meron pong action or motion na nagaganap in vibration, whereby oscillations occur about an equilibrium point. The word vibration comes from the Latin word vibrationem. The oscillations may be periodic, such as motion of a pendulum, or random, such as the movement of a tire on a gravel road. So here are two of the most common movements of vibration, as you can see. So, is an earthquake considered a vibration? Yes, because earthquake is a shaking of the ground. And as I have tackled a while ago, vibration, di ba, is an oscillation. So it it is a back and forth movement at a regular speed. So pasok po doon ng earthquake. And it is usually resulting when there is a sudden break or slip along a fault. Ayan. When two blocks on either side of a fault plane suddenly slip, the energy travels outward from the focus as intense vibration called seismic waves. These waves cause the ground near the epicenter to shake violently. So I will be talking thoroughly about this in the succeeding slide. The seismic waves generated by earthquakes are recorded using seismographs. So for those who are not still familiar with seismographs, I have prepared a visual aid by way of illustration para po makita nyo kung ano po yung seismograph. It is an instrument, by the way, that measures the vibrations in the ground. Yan po ang seismograph. And yung parang recording po, yung parang linya-linya, yan po ang seismogram. Yan po yung data na nakukuha natin sa seismograph. So, what are the three characteristics of a vibration? So, vibration is measured through frequency, amplitude, and phase. First characteristic is frequency. So what is frequency? Frequency, by the way, answers the question how recurrent shaking is. When we say recurrent, gaano kadalas inuulit, gaano nangyayari. So in any aspect, whether in science, mathematics, frequency means gaano kadalas, di ba? It deals with time. It is relevant with or relative with time. So that is frequency. And vibration deals with frequency. Kung gaano ba kadalas nangyayari ang isang shaking or vibration. On the other hand, amplitude answers the question how strong shaking is. When we say amplitude, it is synonymous to intensity. Gaano ba kalakas, gaano ka-impactful ang shaking. Unlike sa phase, ang phase po ay sumasagot sa katanungang how long does it take in shaking. It is somehow relative in time din. Siyempre, how long? It deals with the duration. And phase follows a pattern, a specific pattern. Di ba pag sinabi natin phase, like in meiosis or mitosis phase, di ba meron siyang specific pattern or sequence na sinusunod? Ganun po sa phase. It is somehow relative sa time din, pero ang minimin po ng phase dito ay gaano po katagal ang isang shaking through following a pattern. Ayan. So much for that. For this in this juncture, we'll be discussing the types and elements of vibration. Jessica? Wait lang. I'll just turn my mic off.
Next is vibration, its types, and its elements. Ang vibration daw po ay isang state ng paggalaw ng isang object, mapaharap, patalikod, pakanan, kaliwa, and generally expressed by its four elements: frequency, displacement, velocity, and acceleration. First is frequency. Next. Next slide. Frequency is defined as the number of times something happens in a certain period of time and generates repetitive motion in 1 second. Ang example po nito ay ang pag-alog ng lupa during an earthquake, kung gaano kadalas nauulit o nangyayari ang shaking up and down, back and forth. Next is velocity. Displacement. Displacement is the difference between the initial point of a reference point and any later position. The amount of any point affected by an earthquake has moved from where it was before the earthquakes. The displacement naman po, on the other hand, ay pagbabago ng position ng isang bagay from its reference point and that any position later. Sa isang lindol, maraming bagay ang nababago. Ang katayuan dahil ng pag-uga ng lupa, kaya isa rin ang displacement sa mga bagay na kino-consider upang makita ang damage ng isang lindol. Next is velocity. Velocity is how fast a point on the ground is shaking as a result of an earthquake. Sa velocity naman, kung gaano kabilis ang isang point means isang area or isang lugar mag-vibrate after ng isang earthquake. Next is acceleration. Acceleration, it is the rate at which velocity changes with time, in terms of both speed and direction. A point or an object moving in a straight line is accelerated if it speeds up or slows down. Motion on a circle is appreciated even if the speed is constant because the direction is continually changing. Sa acceleration naman po ay madedefine bilang pagbabago ng bilis ng isang object o bagay. Ang isang lindol ay mayroon ding matatawag na acceleration na nabibase sa paggalaw ng lupa. Ang pinakamataas na acceleration ng isang lindol ang rason ng pagtaas ng velocity ng isang lindol ayon sa recording ng isang station during an earthquake. Next.
Yan, hello po. Whenever there is an earthquake, vibrations are felt, and these vibrations has two types, the surface wave and the body wave. First, let us talk about the surface wave. According to the seismicrelents.org.nz, ang surface wave daw po ay kadalasan nagdegenerate tuwing ang pinanggagalingan ng earthquake ay malapit sa surface ng earth. Kaya nga po ito tinatawag na surface wave. Surface wave can be felt below the ground at mas mabagal daw po ito kaysa sa tinatawag natin S-wave na madidiscuss din natin mamaya. Ngunit, mas malaki naman daw po ang amplitude na dala ng surface wave na kadalasang maituturing na pinakamalakas o pinaka-destructive na klase ng seismic wave. Mayroong several na klase ng surface wave, ngunit ang dalawang pinakakilalang klase nito ay ang Rayleigh waves at ang love waves. Next. Ayan, next. Rayleigh waves. Ang Rayleigh waves, also known as ground roll, ay kumakalat sa lupa bilang ripples. Ito ay mayayain tulad natin sa isang rolling waves ng dagat tulad ng ocean waves. Ang Rayleigh waves ay kayang gumalaw vertically and horizontally. Ayon sa mga eyewitness, sa isang open space area na mayroong Rayleigh wave, ay makikita ang mga sasakyan na gumagalaw taas-baba na parang object sa alo ng dagat. Ang Rayleigh wave din ay typically nagtatravel ng 10% slower kumpara sa S-waves. Next. Ayan, makikita sa litratong ito ang isang Rayleigh wave. Next po. Love waves. Ang love wave ay isa sa kilalang klase ng wave na napaka-destructive sa foundation ng mga structures dahil ng horizontal ground motion na na-generate nito. Ang love wave ay maaari ding mag-cause ng horizontal shearing sa kalupaan at usually mas mabilis din mag-travel ang love wave kumpara sa Rayleigh wave, ngunit mas mabagal pa rin ng 10% kumpara sa S-wave. Next. Now let us talk. Yan, hindi mo pala. Next. Yan. Now let us talk about the next type of vibration. The body wave. The body wave travels in a 3 dimension and can move through the interior of the Earth. Base sa aming pagre-research, ang body wave ay mayroong dalawang existing type. Next. Ang isa nga sa mga ito ay ang P-wave. Ang P-wave o mas kilala sa tawag na primary wave at pressure wave. Ito ay isang klase ng seismic wave na nagtatravel at the greatest velocity through the ground as a longitudinal compressional waveform. Ang P-wave ay nagtatravel tulad ng sound wave na nag-i-spread or nagpo-push or pull habang ang lupa ay gumagalaw dito. Ang P-wave ay kaya mag-travel sa mga solid and liquid object such as rock and ocean. Ang wave na ito ay nagtatravel sa velocity na nagre-range sa 1600 to 1800 meters per second, depending sa material na ginagalawan nila. Dahil sa bilis ng paggalaw nito, ay sila ang unang wave na nagre-register sa mga seismogram graph during an earthquake. Next. Yan, ganito po itsura. Next. S-waves. Ang second type ng body wave na kilala rin sa tawag na secondary wave, shear wave, at shaking wave. Ito ay isang transverse wave form na nag-shear ng kalupaan ng sideways at right angles to the direction of travel. Ang S-wave ay mayroong iba't ibang epekto sa ibabaw ng kalupaan depending on their polarization and direction of travel. Ang horizontally polarized S-waves ay gagalawin ang lupa from side to side, left and right, relative sa direction na ginagalaw nila. Ang vertically polarized S-wave naman ay igagalaw ang lupa pataas at pababa relative sa direction na ginagalaw nila. Ang S-wave daw po ay typically 40% na mas mabagal sa P-wave. Ang velocity nito ay nagre-range approximately 900 to 45,000. Ito ay pangalawang wave na nagre-register sa seismograph ng isang lindol. Bagamat mas mabagal ito kumpara sa S-wave, ito naman ay mas destructive at may mas malaking amplitude na nagkakos ng greater ground shaking.
Dinig po ba ako?
Yes, yes.
Okay, thank you. So, okay, let me just. So, ayun, good morning, everyone. So today I will be discussing attenuation relationships. So this topic will revolve around ground motion parameters and its relationship in predicting earthquake, or at least its effect in our structures. So the first task for us engineers is securing the safety and soundness of our structure. But what will we do if we want to predict ground motions for an earthquake that hasn't happened yet? So, medyo ironic, di ba? Kasi definitely we cannot predict earthquakes, pero we can predict, we can determine how strong an earthquake is. So the best way to do that is to collect and fit equations for them, predicting future ground motion. So for example, we have a site is located right here where the point is, and we have faults that are located around the site at all at various distances. So here's the problem: the earthquake can come from fault one or fault two or three. But in the off chance that we will be able to pinpoint the location of the earthquake, we still won't be able to determine how big it's going to be. But one thing we can be sure of is the distance of our site to this different fault. So this distance, or source to site distance, is a very good parameter to use in an attenuation relationship because it is something that we can predict and know beforehand. So, okay, next book. So with that, let's imagine that we have hundreds and hundreds of ground motion recordings from previous earthquakes. Ayan, next ulit. Ayan. So of course, we know the source to site distance kasi that can be determined naman. Kasi earthquakes only occur sa fault. And from all those recordings, we will be able to obtain ground motion parameters like PGA, or peak ground acceleration, PGV, or peak ground velocity, spectral acceleration, and many, many more. So for example, we will analyze PGA. Yung PGA nga pala, or peak ground acceleration, also known as intensity measure, ay yung measure ng maximum ground acceleration Pero unlike the Richter scale, yung magnitude scale, which measures the earthquake's energy, yung PGA ay measurement of how hard the earth shakes at a given geographic point. Pero iba pa din to dun sa Mercalli intensity scale ha, kasi yung Mercalli intensity scale gumagamit ng personal report and observation. So medyo subjective, sorry, subjective siya. While yung PGA gumagamit ng accelerogram and other instruments. So for every recording we have, we will be plotting the source to site distance from the recording versus the corresponding peak grand acceleration. So ganito yung magiging plot. Paki-next po, please. Ayan. Now, the most common trend that we see is that the further away we are from the causative fault, the smaller the ground motion parameter is. That is why it is called attenuation relationship. Literally meaning na humihina. Like for example, ayan, we draw a line over it. The line tends to attenuate the ground motion parameter in relation to its distance from the fault. So yung line na to, ayan, yung equation ng line na to, pwede natin gamitin to predict the ground motion parameter, in this case, PGA. If, for example, paki-next po, please. Ayan, the distance is this value right there sa R. So there, ayun, nag-project lang siya from that point to that point sa y-axis. Pero, next po, please. Ayan, dito yung problema. This line right here has a lot of scattered data and all those data points don't fall right in that line. So attenuation relationships based solely on source to site distance are pretty scattered and has a lot of variability. With this, next please. Seismologists develop modern attenuation relationships that can be used in design and ground motion prediction in terms of spectral acceleration. So, yung spectral acceleration, parang PGA lang din. Measurement lang din siya na nagde-describe ng max acceleration during an earthquake ng isang object. Gumagamit dito usually ng harmonic oscillator na specifically damped within 5% to plot spectral acceleration over a certain period. Matatandaan natin dyan, dyan sa graph na yan, yung x-axis niya, distance lang, and yung relationship niya sa PGA, yung measured. Pero sa spectral acceleration, nag-add na tayo ng period, which refers to time. Nakalimutan ko lang ilagay yung graph for spectral acceleration. So, Lloyd, pwede ba natin ipakita? Sa Google na lang. Search na lang natin yung sa spectral acceleration. If okay lang.
Sorry, pardon.
Ayan, search mo na lang sa Google. Sorry, hindi ko na-include sa presentation ko. Yung spectral acceleration. I think pag na-search, ayan, sige. Ayan, sorry. Try mo lang i-type sa Google yung spectral acceleration. Pero sige, i-explain ko na lang. So yung spectral acceleration graph, ano siya? Unlike this, kasi di ba dito scattered yung point. Dun sa spectral acceleration graph, lines na siya. Set of lines na yung meaning ng damping na 5%, meaning nagva-vary lang yung equation ng line within 5% ng value ng original or ng true value. Kumbaga, yung different set ng lines ay okay, nawala yung presentation. Ayan, yun. Ayan. So, ayan, nakita na ni Lloyd. So, yun, same set of lines lang. So, yung 5% damping, para lang siyang kumbaga, di ba, sa statistics, di ba, meron din tayong, what do we call that? Yung margin of error, parang ganun, yung damping, exactly, parang ganun. So, variation lang siya ng data, ng true value. Pero of course, hindi pa rin natin ma-attain yung true value. So, yung spectral acceleration, medyo hindi pa rin siya as accurate as we want it to be. So, one way to eliminate variability, kagaya nga ng nangyari dito sa spectral acceleration, is to add more and more independent variables. So, Lloyd, pabalik naman sa presentation natin. Yeah. So, other modern attenuation relationships have a much more complex parameters. So, number one, they may account to fault type like a strike, strip fault, or a normal fault or reverse fault. Number two, fault geometry like the width and depth of the ruptured plane or the length and the area of the ruptured plane. Number three, hanging wall. It can also be whether our site is located on the hanging wall side or the footwall side of the plane. Kasi mas mataas yung movement kapag nasa hanging walls, especially if the shaking is vertical. So next po, please. Ayan. So ayun yung hanging wall. So makikita natin, mag-slide up and down siya, especially if vertical or horizontal yung movement. I mean, either way, vertical or horizontal, mas mataas yung movement sa hanging wall. So next po. Ayan, four, site response effects. This deals with how the local soil that's on top of the fault is amplifying or de-amplifying the ground motions that are being transferred to it during an earthquake. Number five, basin effects. This deals with whether the site is on a basin and how deep is the bedrock on the basin. Kasi bedrock and basins can cause reflections of seismic waves that can cause a lot more damage to our structures. And last but not the least, six, we can also have information on whether we need to predict the effects of the main shock and aftershocks in our site. So, by the way, there are many more attenuation relationships that are much more complex than the six. And the more complex their parameters are, the harder it is to compute by hand. So, these attenuation relationships, syempre, are done, computed, and interpreted using computer programs. So that ends my report, and next we'll be discussing empirical attenuation. Thank you.
Hello po, audible po ba ako?
Yes po.
Yan. Seismic attenuation is an intrinsic property of rock causing the dissipation of energy as seismic wave propagated through the subsurface. Halimbawa, you throw a pebble in a pond. Nag-create ito ng wave sa surface papalayo kung saan mo binato yung bato. The waves are largest kung saan tumama ang bato and get smaller as they move away. It results in the decay of amplitude of the seismic waves. In addition, attenuation is related to velocity dispersion. Next po, please. Seismic waves become attenuated as they move away from the earthquake source. In addition, the energy of seismic wave is conserved if it travels through a perfect elastic medium. So ano-ano naman yung mga factors na nagre-result sa loss of energy ng propagation ng seismic waves? Una yung geometrical spreading or tinatawag din siya minsan na spherical spreading. Then meron tayong absorption or anelastic attenuation, and lastly ay yung scattering or elastic attenuation. Marami pa siyang ibang factors pero let's focus muna sa tatlong ito. Next po. Yung una po natin ay yung geometrical spreading. In geometrical spreading, seismic waves amplitude vary as they travel across the earth. As the wave fronts move out from the source, the initial energy released in the seismic wave is spread over an increasing area, and therefore the intensity of the wave decreases with the distance. Sa madalit sabi, the wave are largest when they are formed and gradually get smaller as they move away. Gaya naman po yun ang sinabi ko din kanina sa unang part ng aking report. Next po please. Next po ay yung ating anelastic attenuation. This is the energy loss due to an elastic process or internal friction during wave propagation. This is called intrinsic or anelastic attenuation. Intrinsic attenuation occurs mostly during shear wave motion associated with lateral movement of lattice and grain boundaries. Sabi ko nga din po kanina, attenuation happens on a perfect elastic medium. Kapag nagkakaroon ng internal friction, most of the energy of the seismic wave absorbed by the ground, and doon po nababawasan yung energy propagation ng ating seismic waves. Next po. Pa-next po ako. Hello po.
Kasi nawalan yata ng kuryente kila Lloyd. Bigla lang. Continue ka lang, tapos sort out namin yung presentation habang nag-report.
Ayun po. The last part is about scattering. Scattering is different from other type of attenuation since the integrated energy in the total wave field remain constant. Attenuation is a frequency dependent and is strongly affected by scattering. Scattering is an important factor caused by heterogeneity of the earth crust and mantle and the availability of hydrocarbon reservoir. Scattering theory states that rock containing oil and gas can cause energy attenuation in the seismic wave, particularly the high-frequency wave passing through them. Frequency-dependent attenuation can use to detect hydrocarbon. In addition, scattering of high-frequency seismic wave demonstrate the existence of small-scale heterogeneity in the lithosphere. The scattered wave are incoherent since the scatterer are considered to be randomly distributed. Naku, paano to? Wait, nasan yung ano? Wait lang po, check ko lang po kung meron akong copy ng PowerPoint.
Ayan na ulit si Lloyd. Wait natin yung
Okay na.
presentation.
Pa-next na po ako. Next pa po ulit. Yan, dito naman po makikita natin yung variation ng attenuation with the frequency na nakakatulong sa paglo-locate or pagmamap ng reservoir containing the oil and gas. Sabi ko nga po dun sa scattering theory, yung mga rock daw po na nagko-contain ng oil and gases ay nagiging factor sa energy attenuation sa seismic wave. Next po, please. Yun po, scattering is computed using ratio of the inhomogeneity of medium A to a wavelength. We use formula K is equal to 2 pi over wavelength. Tapos po, if Ka is less than 0.01 or yung quasi-homogeneous medium, there are no significant scattering. If Ka is less than 0.1 or yung Rayleigh scattering, it produces apparent Q and anisotropy. If Ka is less than 10 and less than 0.1 or Damay scattering, it produces strong attenuation and distinguishable scattering in the signal. Next po, please. Yan, the quality factor. Attenuation is measured by dimensionless quality known as the rock quality factor Q or the attenuation factor. It is assumed that Q is linked with the physical state of rock. Q is the ratio of stored energy to dispersed energy. It measures a relative energy loss per oscillation. Q increases when the density and velocity of the material increases. In Earth's crust, Q ranges from 10 to 100. Next po. Para makuha yung quality factor, we will use the formula Q is equal to energy of a seismic wave over the energy lost during one cycle of wave. Or yung ating 2 pi E over delta E, where E is the energy of the seismic wave and delta E is the energy change per cycle. Next po. Next po ay makikita natin yung typical Q value sa Earth. Kung ma-observe po natin, QP is larger than QS. This is due to the fact that the intrinsic attenuation is predominantly caused by shear motion involved between particle and grain boundary that cause the frictional heating. Next po. Yan, global attenuation model has been obtained from normal mode to surface wave display. The highest attenuation is in the asthenosphere and the inner core, and the low attenuation is in the lithosphere or the lower mantle. Global surface wave attenuation model correspond closely to the shear velocity, suggesting that temperature is the controlling factor. Next po. wala na po pala akong part. Thank you po.
Ayan, so, if you have questions, you can ask them now. Kasi magkaka-quiz tayo. Di, syempre, kagaya ng ibang groups, may prize din, syempre. So, if may questions kayo, sabihin nyo na para, syempre, pataasan sa quiz later. So, Lloyd, send mo naman yung link ng quiz natin so everyone can open the site. Pati yung code din pala. Baka makalimutan natin.
Ayan, hold on a minute lang po tayo guys. Pasensya na po kanina sa nagkaroon lang po ng sudden power outage dito sa amin. Ayan. Ayan, may sinend po akong link sa in-call messages sa Meet. Maki-check naman po kung functional. Thank you.
Ano pong code?
Ayan, naka-share screen po yung natin, code. Sinend ko na rin sa in-call messages. Ayan, so far meron po tayong 19 participants, 20. Maghihintay po kami until 8:15.
Tayo. So, dapat meron diyang 26, 25 participants. Join na kayo. May prize and prize.
Ayan, wala na po bang magpa-participate? Start na po tayo. Sige po. Start na po tayo. Ayan, just click start po and play the game. Good luck. Ayan, hihintay na lang po natin yung dalawang players. Ayan, I think may winner na po tayo. And our top 3. Ayan. Ayan, and our winner is Yvonne Cute Walang Titi Bag. think it's-
Ivy, ikaw ba yan?
Si Ivy yata
Ayan,
ito.
si Ivy nga. So, sino yung
Sino tong
si
second?
Josh? Si Joshua Sereno ba? Or si Joshua Magsino? Pakigalaw ng baso, guys.
Ayan si Magsino, si Joshua.
Ayan, si Joshua
Magsino.
Magsino. Then, I think si
Ayan,
Chantel
congratulations.
number 3.